In this video, we will be covering addition of vectors SAQs. So students kindly focus onto the solutions very attentively. So the first question says A, B, C, D, E, F is a regular hexagon. Hexagon means it has 6 sides. So let us try to draw a hexagon. It's something like this, right? And the center is O, right? Center is O. So A, B, C, D, E, F. Then prove that AB vector. So students, what most of you do is we write AB vector as AB only. So if you write it in this way, you will be not awarded any marks. AB vector means there should be direction also mentioned. I hope you understood this. AB vector should be written in this way, and this way should be completely avoided. So we need to prove that AB vector plus AC vector plus AD vector plus AE vector plus AF vector is 3 times AD vector, which is equals to 6 times AO vector, right? So what should we do? So see, we need 3 times AD vector, right? We have one AD vector already. So let us not disturb that. Let us write this AD vector as it is. So this AD vector we are writing as it is. Next, we will write AB vector here. And then we have AC vector, and then we have AE vector, and we have AF vector. We are taking LHS, dear students, right? I hope you understood this. Now AD vector we will not disturb. We have AB vector here, and AC vector is this. AC vector is this, right? And AE vector is this. AE vector is this, and AF vector is this. Now dear students, can we write one thing? Can we write AF vector is equals to CD vector? Direction ratios are same because they are parallel. AF is parallel to CD, right? That means AF vector is also parallel to CD vector. So we can, and since it is a regular hexagon, AF vector should be equals to CD vector because it is a regular hexagon. So we will write AF vector as CD vector. Okay, and then we will also write, see, AE is parallel to BD, right? Also AE vector is parallel to BD vector. AE vector, this is AE vector, it is parallel to BD vector. I hope you understood this, right? And since it is a regular hexagon, can we say AE vector is equals to BD vector? See, regular hexagon means all the sides are equal. So we will do one thing, we will replace AF vector with CD vector. We will replace AF vector with the CD vector. Okay, let us write CD vector here. And we will replace AE vector with the BD vector. AE vector with BD vector. Now, dear students, we will club these two and these two. See, in vectors, we have very important thing that, okay, let me write AB vector plus a BD vector here and plus AC vector plus CD vector here. Now, when these two are equal, no, we can write this equivalently as AD vector. Now this can equivalently be written as AB vector plus BD vector is nothing but AD vector. Just see the first point and the last point. Similarly, here the end point for the first vector and the starting point for the second vector are same. So we can write AC vector plus CD vector as, yes, you guessed it right, it should be AD vector. I hope you understood it, dear students. This is a very, very simple question. Please practice this. So we have AD vector plus AD vector plus AD vector is 3 AD vector. I'm once again reminding you, dear students, we need to keep the direction here, right? Now we also should prove that 3 AD vector is 6 times AO vector. See, AD vector is this. AD vector. Now from the diagram, can we say AD vector is 2 times AO vector? Since it's a regular hexagon, O is the center or O is the midpoint of AD. So can we say AO is equals to OD? Yes. So instead of AD vector, can we write 2 AO vector? Yes. So here we'll write 3 times 2 into AO vector, which is nothing but 6 times AO vector. I hope you understood this, dear students. So that's it. We have proved, hence proved. Please practice this question once again. Now let us go to the next question. Next question says, in a triangle ABC, let us draw the triangle ABC. So we have triangle ABC. O is the circumcenter. O is the circumcenter. H is the orthocenter. Then show that. See, dear students, just remember one point. Whenever we have circumcenter and orthocenter, write this part. H, G, O. What does H represent here? Orthocenter. he has given in the question, and O is circumcenter, he has given in the question, and G is centroid. So centroid divides orthocenter and circumcenter in the ratio 2:1. Now if you get confused how to remember whether it is 2:1 or 1:2, think in this direction. This is 0, then we have 1, then we have 2, 0, 1, 2. Think in that direction, okay? Anyways, so now let O be the origin. So I'm assuming that O be the origin. Then we need to prove that OA vector plus OB vector plus OC vector is equals to OH vector. See, dear students, can we, in the first option, we don't have any G, right? We have OA vector plus OB vector. So now, OG vector should be equals to, now this is centroid, right? This should be equals to OA vector plus OB vector plus OC vector divided by 3. By definition, dear students. Hope you understood this. Centroid is, in 3D, we write x1 plus x2 plus x3 by 3. So in that way, OG vector is OA vector plus OB vector plus OC vector divided by 3. Now cross multiply 3 times OG vector is equals to OA vector plus OB vector plus OC vector. Now see, we need OH vector here. Very simple, dear students. From the diagram, from this diagram, right? From this diagram, or can we say, see the entire length. Now let us say this is 2k, this is k. So the total length should be 3k. Correct? No? So can we say 3k is equals to 3 times k? Looks very simple and correct, no? 3k is nothing but 3 times k. Now can we say 3k is nothing but OH vector magnitude that will be equals to 3 times OG. I hope you understood this. Entire length of OH is thrice the length of OG. Yes or no? So instead of 3 OG here, we can write OH vector. That's it, dear students. OA vector plus OB vector plus OC vector is nothing but equals to OH vector. So the first part is proved. It is as simple as that. Now we need to prove that second part, that is HA vector plus HB vector plus HC vector. So we will take the LHS for the second part. So this is the first part. So next part we will write HA vector plus HB vector plus HC vector. Now in vectors, you remember one thing, AB vector can be written as OB vector minus OA vector, right? We can write this, right? So you remember this. So with respect to that, HA vector can be written as OA vector minus OH vector. HB vector can be written as OB vector minus OH vector, and HC vector can be written as OC vector minus OH vector. Now OA vector plus OB vector plus OC vector is, we just proved that is OH vector, right? OH vector, and what remains is minus OH minus OH minus OH is minus 3 times OH. Now OH minus 3 times OH vector is minus 2 times OH vector. Now here when we reverse the direction, we can write this as 2HO vector. I mean AB vector is minus BA vector, no? So with that logic, minus OH vector is HO vector. Did you understand? Yeah. Hope you understood this. So that's it. I think we have to prove that it is equal to twice HO. That's it, dear students. The question is as simple as that, and these are very, very important questions, dear students. Please rewind the video and watch it if you have not understood. The next is also a very important question. It says, if the points whose position vectors. So what will I do is, let OA vector, I'm once again reminding you, please keep the arrow, is this is equals to 3i cap minus 2j cap minus k cap, and OB vector is this 2i cap plus 3j cap minus 4k cap, and OC vector is this part. OC vector is minus I cap plus j cap plus 2k cap, and OD vector is this, is 4i cap plus 5j cap plus lambda k cap. Now he has given that these vectors are coplanar. Very important condition, dear students. Remember that box AB, AC, AD is equals to 0. We need, this is condition for coplanarity, not collinearity, coplanarity, okay? Then show that lambda is equals to minus 146 by 17. We have to prove that. So we have to find AB vector first. So AB vector is OB vector minus OA vector. We have discussed at this point in the previous question also. OB vector minus OA vector, what will that be? 2i cap minus 3i cap is minus I cap. Directly I am writing 3j cap minus of minus 2j cap. Okay, if you are not understanding it, let me write it here. OB vector is 2i plus 3j minus 4k minus OA vector is 3i minus 2j minus k. So dear students, why am I writing this? Because most of you don't keep the negative sign or you swallow the negative sign. That's why I'm writing this here. 2i minus 3i is minus i. 3j minus of, see, minus into minus is plus. So what do we get? 3j plus 2j. It should be plus 5j. Hope you understood this. Minus 4k. Now minus into minus again is once again plus. Minus 4k plus k is, yes, it should be minus 3k. Please redo this once again. Most of you will do wrong in this question, this step only, right? So similarly, AC vector should be OC minus OA. So minus I minus 3i is minus 4i plus j minus of minus 2j should be plus 2j. I repeat, plus j. Now here we directly don't write minus 2j, so because it is OC minus OA, right? OC minus OA, it becomes, this becomes plus 2j, right? J plus 2j should be plus 3j plus 2k plus k. Again, 2k minus of minus k is plus k. 2k plus k is plus 3k. Students, let us say this is 2, okay? Now AD vector is again OD minus OA. Let me write it. OD vector is 4i cap plus 5j cap plus a lambda k cap minus OA vector is this 3i cap minus 2j cap minus k cap. Please don't forget to keep the bracket here. 4 minus 3 is I, 5 plus 2 is 7, lambda plus 1. So this should be lambda plus 1 times k cap, right? Now how do we write this determinant, dear students? Determinant of AB or box of AB, AC, AD. This we write it in this way. We will write the first vector AB. In the first row, we will write minus 1, 5, minus 3. We will write the coefficients of ijk in the first row. We will write the coefficients of ijk of second vector in the second row. Minus 4, 3, 3. And we'll write the coefficients of ijk of the third vector in the third row. That will be 1, 7, lambda plus 1. I hope this is clear. This should be equals to 0. Now expand determinant. Expand the determinant along row 1. As such, any row or any column works. I'm expanding along row 1. So we will get minus 1 times. So here we will write 3 times lambda plus 1 minus 7 into 3. Next we will write minus 5 times. Again minus 4 times lambda plus 1 minus 1 into 3. I hope you understood this. Again we have minus 3 here. Let us write minus 3 times minus 4 into 7 minus 1 into 3. Right? This should be equals to 0. So let us expand this. Minus 1 times 3 lambda plus 3, now plus 3 minus 21. Now here we have minus 5. Minus 4 into lambda is minus 4 lambda. Minus 4 into plus 1 is minus 4. Now we have minus 3. And again we have minus 3. Minus 7 into 4 is minus 28 minus 3. This is equals to 0. I hope you are with me till here. Now we will get minus 1 into 3 lambda is minus 3. 3 minus 21 is minus 18. Minus 18 into minus 1 is minus 18 into minus 1 is plus 18. Yeah, now minus 5 into minus 4 is plus 20 lambda. Minus 4 minus 3 is minus 7. Minus 7 into minus 5 is plus 35. So we have minus 28 minus 3 is minus 31. Minus 31 into minus 3 should be, so 31 into 3, I think it is 93, right? It is 93. Let me write it here. Now minus 3 lambda plus 20 lambda is 17 lambda. 18 plus 35. So 35 plus 18, 8 plus 5 should be 13, 3 plus 1 is 4, 53. So this should be 146, I think. 53 plus 93 is 146. So therefore, lambda will be minus 146 divided by 17. That's it. We have to prove this, right? So we have to prove that lambda is equals to minus 146 by 17. Hence, proved. So this is the answer for the previous question. So students, I recommend all of you to kindly solve these questions without seeing, so that you are thorough with this. Thank you for watching the video once again.